The National Electrical Code requires the use of NEMA 4 enclosures in specific locations where the equipment is subject to moisture and other hazards. Article 110.11b states that enclosures for electrical equipment shall be provided to protect persons from accidental contact with energized parts, to prevent the entrance of foreign objects, and to prevent the accumulation of moisture that may do any of the following. 1. Cause an electrical breakdown. 2. Interfere with the safe operation of the equipment. 3. Prevent access to live parts. Article 530.21b states that where elevator hoistway equipment is exposed to moisture or other injurious conditions, the equipment shall be enclosed in corrosion-resistant enclosures suitable for the conditions. While the NEC does not specifically mention elevator pits with fire protection heads as requiring NEMA 4 enclosures, the code sections previously mentioned require the use of moisture-resistant enclosures in areas where moisture or other hazards are present. In the case of an elevator pit, the presence of a fire protection head indicates that the area is subject to moisture from water discharged during a fire. Therefore, an inspector may reasonably require the electrical installation within the pit to be enclosed in NEMA 4 enclosures to comply with the NEC requirement to protect equipment from moisture and other hazards. The NEC does not specify the specific enclosure type NEMA 4, but it does reference the NEMA standards. According to NEMA 250, NEMA 4 enclosures are defined as suitable for indoor or outdoor use, protecting against rain, sleet, snow, wind-blown dust, splashing water, hose-directed water, and corrosive agents. The interpretation of code requirements often comes down to ensuring safety and preventing potential hazards. The presence of a fire suppression system in an elevator pit introduces the reasonable expectation of moisture exposure. The goal of the electrical code is to safeguard people and property from hazards arising from the use of electricity. Article 100 defines approved as acceptable to the authority having jurisdiction. The authority having jurisdiction is defined as the organization, office, or individual responsible for enforcing the requirements of a code or standard, or for approving equipment, materials, an installation, or a procedure. The inspector is the authority having jurisdiction in this scenario. They are tasked with interpreting and enforcing the code based on their understanding of the specific installation and potential risks. The code aims to prevent electrical breakdowns, interference with safe operation, and prevent access to live parts. This is achieved through various means, including proper wiring methods, overcurrent protection, and suitable enclosures. Moisture can compromise the integrity of electrical insulation, leading to short circuits, ground faults, and potentially dangerous situations. The presence of water can also accelerate corrosion of metal components, further increasing the risk of failure. Electrical equipment installed in damp or wet locations must be suitable for the environment. This often means using enclosures that are specifically designed to protect against moisture ingress. Article 430.11 addresses protection from liquids for motors. Motors must be located or arranged so that adequate ventilation is provided and so that they cannot be injured by dripping or splashing water, dust, or damaging fumes. Article 430.101 discusses disconnecting means for motors. A disconnecting means must be provided for motors and their associated control equipment. The disconnecting means must be readily accessible and capable of being locked in the open position. Article 430.102 covers location of disconnecting means. One disconnecting means must be located in sight from the motor controller location. The controller disconnecting means could be installed adjacent to the motor disconnecting means. The second disconnecting means must be located in sight from the motor and driven machinery location. Article 430.109 lists types of disconnecting means. The disconnecting means can be a motor circuit switch, a circuit breaker, or a molded K-switch. Article 430.110 covers amperage of disconnecting means. The disconnecting means must have an ampere rating of at least 115% of the motor's full load current rating. For motors with higher voltage ratings, such as 600 volts, additional safety precautions are necessary. High voltage systems pose a greater risk of electrical shock and arc flash, requiring more robust insulation and protection measures. The selection of appropriate NEMA-rated enclosures is essential for ensuring the safety and reliability of electrical installations in various environments. Different NEMA ratings offer varying degrees of protection against environmental factors such as dust, water, and corrosion. Understanding the specific requirements of each NEMA rating is crucial for choosing the right enclosure for a particular application. A NEMA 1 enclosure is intended for indoor use primarily to provide a degree of protection against contact with the enclosed equipment in locations where personnel ordinarily have access. A NEMA 2 enclosure is intended for indoor use primarily to provide a degree of protection against limited amounts of falling water and dirt. A NEMA 3 enclosure is intended for outdoor use primarily to provide a degree of protection against rain, sleet, wind-blown dust, and damage from external ice formation. A NEMA 3R enclosure is intended for outdoor use primarily to provide a degree of protection against rain, sleet, and damage from external ice formation. A NEMA 3S enclosure is intended for outdoor use primarily to provide a degree of protection against rain, sleet, wind-blown dust, and damage from external ice formation. Also, it is constructed so that the external operating mechanism remains operable when ice-laden. A NEMA 4 enclosure is intended for indoor or outdoor use primarily to provide a degree of protection against splashing water, hose-directed water, the entry of water, and damage from external ice formation. A NEMA 4X enclosure is intended for indoor or outdoor use primarily to provide a degree of protection against corrosion, splashing water, hose-directed water, the entry of water, and damage from external ice formation. A NEMA 5 enclosure is intended for indoor use primarily to provide a degree of protection against settling airborne dust, lint, fibers, and flyings. A NEMA 6 enclosure is intended for indoor or outdoor use primarily to provide a degree of protection against the entry of water during occasional temporary submersion at a limited depth. A NEMA 6P enclosure is intended for indoor or outdoor use primarily to provide a degree of protection against the entry of water during prolonged submersion at a limited depth. A NEMA 7 enclosure is intended for indoor use in hazardous locations classified as Class 1, Groups A, B, C, or D. A NEMA 8 enclosure is intended for indoor use in hazardous locations classified as Class 1, Groups A, B, C, or D. A NEMA 9 enclosure is intended for indoor use in hazardous locations classified as Class 2, Groups E, F, or G. A NEMA 10 enclosure is a United States Bureau of Mines enclosure. A NEMA 11 enclosure is intended for indoor use primarily to provide a degree of protection against the corrosive effects of liquids and fumes. A NEMA 12 enclosure is intended for indoor use primarily to provide a degree of protection against dust, falling dirt, and dripping non-corrosive liquids. A NEMA 12K enclosure is intended for indoor use primarily to provide a degree of protection against dust, falling dirt, and dripping non-corrosive liquids. A NEMA 13 enclosure is intended for indoor use primarily to provide a degree of protection against dust, spraying of water, oil, and non-corrosive coolant. When selecting enclosures, consider not only the NEMA rating but also the material of construction. Metal enclosures, such as steel or aluminum, offer robust protection against physical damage and are suitable for demanding industrial environments. Non-metallic enclosures, such as fiberglass or polycarbonate, are lightweight and corrosion-resistant, making them ideal for applications in corrosive or wet environments. Consider the ambient temperature range in which the equipment will be operating. Electrical components generate heat during operation, and excessive temperatures can lead to premature failure or reduced performance. Ensure that the enclosure is adequately ventilated or cooled to prevent overheating. Consider the ease of installation and maintenance when selecting enclosures. Choose enclosures with features such as removable panels, hinge doors, and accessible mounting points to simplify installation and maintenance tasks. Consider the size and weight of the enclosure, especially in applications where space is limited or where the enclosure needs to be mounted on a wall or ceiling. Choose enclosures that are compact and lightweight without compromising on protection or functionality. Always follow manufacturers' recommendations and industry best practices when installing and maintaining electrical enclosures. Proper installation and maintenance are essential for ensuring the long-term reliability and safety of electrical equipment. Article 300.3 addresses conductors. Single conductors must be installed in raceways. All conductors of the same circuit must be installed in the same raceway. Article 300.4 discusses protection against physical damage. Wiring methods must be protected from physical damage. Where cables pass through metal studs or metal joists, they must be protected by bushings or grommets. Article 300.5 covers underground installations. Underground wiring must be buried at a sufficient depth to protect it from physical damage. The minimum burial depth depends on the voltage of the circuit and the type of wiring method used. Article 300.7 addresses raceways exposed to different temperatures. Where raceways are exposed to different temperatures, condensation may occur inside the raceway. To prevent condensation, the raceway must be sealed or ventilated. Article 300.11 discusses securing and supporting wiring. Wiring must be securely fastened and supported. Cables must be supported at intervals not exceeding 1/2 feet. Raceways must be supported at intervals not exceeding 10 feet. Article 300.14 covers length of free conductors at outlets and switch points. At least 6 inches of free conductor must be left at each outlet and switch point for making connections. Article 300.15 addresses boxes, conduit bodies, or fittings required where conductors are spliced or terminated. Conductors must be spliced or terminated in boxes, conduit bodies, or fittings. These enclosures provide protection for the splices and terminations and prevent them from coming into contact with other objects. The proper application of NEMA for enclosures hinges on a clear understanding of the environmental conditions and potential hazards present in the specific location. While the NEC doesn't explicitly mandate NEMA for enclosures for elevator pits with fire suppression systems, the code's overarching emphasis on protecting electrical equipment from moisture and other detrimental factors provides a strong basis for requiring such enclosures. Always consult with a qualified electrical inspector or engineer to determine the most appropriate enclosure type for a particular application, taking into account all relevant factors and code requirements. This proactive approach will help ensure the safety, reliability, and longevity of electrical systems in diverse environments.